Okay, we're going to talk about the unit circle. So we're going to start off by revisiting sine, cosine, and tangent. So sine, as you might remember, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So we go over here and we say, okay, well, sine opposite over hypotenuse, right? And cosine is adjacent over hypotenuse, right? Adjacent means it's touching it. Now, what if the hypotenuse was 1? Then if the hypotenuse was 1, then sine would simply be equal to the opposite side. And if the hypotenuse was 1 here for the cosine, we would simply have cosine of the angle equals the adjacent side. So the adjacent side represents the distance in the x direction, and the opposite side represents the distance in the y direction. And that's really, really important for when we're trying to figure out the unit circle. So like I just said, the sine is going to represent the distance in the y direction, and cosine equaling adjacent, it's going to represent the distance in the x direction. So you might want to pause and think about that, or maybe even replay. Okay, so now we come back to this. So let's think about the coordinates 0, 0. If I drew this tiny little triangle right here, so tiny that it has no height. So what is the y value on this thing right here? So the y value is equal to 0. So sine of 0 is going to be 0. Now, what about the x direction? In the x direction, it goes all the way over, and so the x value is 1. So for cosine, I'm going to have a value of 1. Okay, so now let's look at 90 degrees. At 90 degrees, we're up here. My triangle would have be so tall. So the triangle would have a height. The height would be 1. Oops. The height here would be 1. And the x value, because if it's 90 degrees, it's going straight up. So the x value is going to be 0. Now let's think about, what if we're at 180 degrees? At 180 degrees, there's my triangle there. It has no height. So if there's no height, the y value is 0. And but the x value is the value going this way, and that's going to be equal to 1. I hope you're starting to see a pattern here. Now 270 is down here. So my triangle has an x value of 0 and a height of -1. Oops, I made a mistake over here. At 180, the y value is -1. So I needed to change sorry, the x value is -1. Okay. 360, we're back here, and the x value, which is cosine, is 1, and the y value because it doesn't go up and down, that y value is going to be 0. Now -90, if I went clockwise from 0, I would be down here. So -90 is going to have the same values as 270, so it's going to be -1 and 0. And 450 is just going to be 360 plus 90, and that's going to give me the same. So the y value is going to be, sine is the y value is going to be 1, and the x value is going to be 0. Okay. So using this information, we're going to now graph a sine wave and a cosine wave. Okay. So I copy the information really quick here. Okay, and we're going to use this information to plot some points. And then I'm going to tell you guys how the wave normally goes. So let's start off with at 0. So we're going to make a sine wave here. And we're going to make a cosine wave here. Okay, so my sine wave at, okay, well, let's start at negative 90. So my sine wave, we're at negative 1, and at 0 degrees, we're at 0. And at 90 degrees, I'm at 1. And at 180, we're at 0. At negative 270, we're at negative 1. At 360, we're at 0. And at 450, we're at 1. Okay? Now let's plot the cosine values. So at negative 90, we're at 0. At 0 degrees, we're at 1. At 90 degrees, we're at 0. At 180, we're at negative 1. At 270, we're at 0. And at 360, we're at 1. And at 450, we're at 0 again. Okay, so if I was to get a lot more points, we would eventually notice that we have a sine graph that looks like this. Okay, and for math applications, all you need to know is that when you go through this process of the unit circle, that you end up with a sine wave and cosine wave. Okay, so now what's interesting about this is just like this, except it's shifted over 90 degrees, isn't it? It's exactly the same, it's just shifted over. Okay, so so we're going to talk about some trig identities also. So in Algebra 2, you might have learned that x squared plus y squared equals r squared for a formula for a circle. Okay, so you may have learned this in Algebra 2. The formula for a circle is x squared plus y squared equals r squared. Now, on our unit circle, the radius is equal to 1, right? So this is going to be 1. And we just said the x value is represented with what? The x value is represented with cosine. So I've got cosine squared theta. And the y value is represented with sine, so we've got sine squared theta. And that's equal to 1. So this is one, it's called a trig identity. Okay. And now another trig identity is that sine negative theta is equal to negative sine theta. Okay. So what this is saying is, if I made all of these angles negative, then I would have, so if I wanted this to be over here, so if I'm at negative 90, to be at 90, I would have to change the sign of it to be a positive one, because if I plugged in negative 90 here, we would have negative 1. And we know that sine of 90 is positive 1, so that's what this negative is going to identify that. Okay, now cosine's a little different. The cosine identity is And the reason you can remember this, now all of these formulas are in the IB formula packet. You don't need to remember these. You can just find them in your formula packet. So, and they're all right. Oops. So these formulas are right here. Okay. So, and one more formula identity is that tangent theta is equal to sine theta over cosine theta. And the way you can remember this, an easy way to remember this, is you might recall the tangent is opposite over adjacent, right? And so I could replace adjacent with cosine, and I can replace opposite with sine. And by doing that, you end up with this trig identity. Okay, and that should be everything you need to know for your lesson today. Please let me know if you have any questions.